Hello everybody, in this video we're going to talk about how to find the area of a regular polygon. So what we see on the screen right here on the left is a hexagon, a regular hexagon, and we have the center point and we have a couple radii of the hexagon, or if we were to circumscribe a circle around, those would be the radius of our circle, okay? And now the distance that we have from our center to the edge of our hexagon, remember we're labeling it with A, that is known as the apothem. And we've done a previous video on what an apothem is, so I'll link that in the top right hand corner right now. So let's talk about how to find the area of a regular polygon. Well, on the right side we see it's the area of one triangle times the number of triangles that we could make inside this regular polygon. So here we have a hexagon, and essentially what we could do is draw these segments to each of our vertices of our polygon, and in this case our hexagon. And that's going to give us our number of triangles, right? So this is 1, 2, 3, 4, 5, and 6, okay? So we have 6 triangles here. And if we think about the one triangle that we have right here, where we have some things labeled, the apothem, and we have S for just the side length of the hexagon here. So if we think about area in terms of being 1/2 base times height. So here we're going to say area is equal to 1/2. Well, in this case, our base would be S, and our height would be the apothem. Okay. All right. And so now we're going to multiply that by the number of triangles that we have in the shape. Okay. So now we're going to say area is equal to 1/2, and let's move A to right here and S close to or next to N, right? We can do that commutative property of multiplication. So now if we think about what is S times N? Well, S would be the side length of just one of our segments right here, right? So if we multiply that by the number of sides we have, essentially we are finding the perimeter of our shape. So now we can write this, the most simplified version, 1/2 times the apothem times the perimeter of our shape, okay? And so that's going to be our formula that we're going to be working with today in this video. And so let's look at about 3 examples and find the perimeter of our polygons. All right, example number 1, we're going to find the area of the hexagon. And we are given that the length, the diameter here would be 32. So now we know that this segment here would be 16. And now we can use our central angle of our hexagon here to determine what this angle would be, right? Remember, our central angle is going to be this entire angle right here. And so our apothem, or our altitude here, where we have our right angle box, that is going to bisect our central angle. So if we have a hexagon and we want to do 360 divided by the number of sides, that's going to be 360 divided by 6. And that's going to tell me that my central angle is 60 degrees. So now, since my central angle is 60 degrees, this angle here is 30 degrees. So now we've created a special right triangle, a 30, 60, 90. And we know there's a relationship between the side lengths of a 30, 60, 90. I'll link that video right now. But now we know the hypotenuse here is 16. So the small side, or the shorter leg, is going to be half of the hypotenuse. And the longer leg is going to be the small leg times root 3. So now what we can do is we have all the information we need. We can say area is equal to 1/2 times the apothem times the perimeter, okay? So now we know area is equal to 1/2. Our apothem here is 8 root 3. And our perimeter, okay, well, if this side, if our small side down here is 8, then our entire distance here would be 16. And so now we can do 16 times 6, and that gives us 96. Okay, so now we have area is equal to 1/2 times 8 root 3 times 96. And we can just type this in our calculator, multiply by 8 root 3, and then divide by 2. Okay, so our area here is going to be approximately 665.11, and we'll just call it square units. Okay, all right, example 2. Find the area of the regular octagon. All right, so now here we're given the length of our apothem. So we have area is equal to 1/2 times the apothem times the perimeter. So we are given, or excuse me, we're not given the apothem, we are given the, essentially what would be the radius if we were to circumscribe a circle. So our apothem is going to be this vertical distance right here. So that's what we need to find, okay? So we know the perimeter, if we have an octagon, then the perimeter is going to be 15 times 8. So we can do 15 times 8, and we get 120. So we can come back to that and add that into our area formula in just 1 second. All right, so now we know that this entire side here would be, this entire side here would be 15. So since we are dropping this apothem here, it is going to bisect the side. So now we know this side would be 7.5 inches. So now to find our apothem, we can just use the Pythagorean theorem. We can say a squared plus b squared equals c squared. And we'll say a squared is our apothem, 7.5 squared equals 19.6 squared. So we'll do 7.5 squared and 19.6 squared. So now we have a squared plus 56.25 equals 384.16. So now let's move our 56.25 to the other side. So now we have a squared equals, so minus 56.25. And now this is 327.91. And lastly, we're going to take the square root. So now we have a is equal to, and for right now, I'm going to leave this as square root. I'm just going to say the square root of 327.91. Okay, so now we know what a is equal to. We know what p is equal to. We can plug all of this in. So our final formula would be a equals, area is equal to 1/2 times the square root of 327.91 times our perimeter, which was 120. Okay, so now I'm going to take the square root here of my previous answer, which was 327.91, multiply that by 120, and then multiply that by 1/2. So now we are given an area of 1,086.5, and we'll say square inches. Okay, let's look at one more example. All right, now we want to find the area of the nonagon, right? Nonagon, remember, is 9 sides. Okay. All right, so and all we're given here is that one of our sides is 6 inches. So if our area formula is 1/2 times the apothem times our perimeter, we can go ahead and find perimeter. We know that perimeter would be 6 times 9 because we have 9 sides. So our perimeter is 54 inches. So we can save that information for later. Now let's add in, let's say that's our center, and we want to make a triangle here. So we add those in, and let's add in our apothem. Okay, so that's what we need to figure out. All right, so now let's find out what our central angle is. So we're gonna do 360 and divide that by 9. So we get 40. So now what we know is this is a 20-degree angle because we are bisecting it, okay? So now if that's 20 degrees, and we are essentially splitting this side in half, let's say that this little side here is 3 inches. So now we can use a trig ratio to find our apothem. If we think about 20 degrees, we have the opposite side, which is 3. We need the adjacent side. So opposite over adjacent, that's tangent. So we want to find the tangent. We're going to say tangent of 20 is equal to opposite over adjacent. We'll just say, actually instead of x, let's go with a because that's going to stand for apothem. Okay. So now I'm going to multiply both sides by a here because that's going to give me a times the tangent of 20 is equal to 3. And now we can divide by the tangent of 20. So now we can say that a, or our apothem, is equal to 3 divided by the tangent of 20. And I'm going to leave that right there for now because we're going to plug that in our area formula right now. So now we have area is equal to 1/2 times our apothem, which is 3 divided by tangent of 20, and then times our perimeter, which is 54. So now we can type all this in our calculator. I'm going to go ahead and do 3 divided by tangent of 20, and I'm going to multiply that by 54, and I'm going to multiply that by 1/2. So we get an area of approximately 222.5 square inches. Okay, and that is how you find area of a regular polygon.